Lockheed Martin has officially entered the full-rate production phase for the Precision Strike Missile, or PrSM, marking one of the most rapid industrial accelerations in the modern history of U.S. missile manufacturing. The company is gearing up to produce as many as 400 missiles annually, a scale that signals both the maturity of the program and the urgency the U.S. Army places on expanding its long-range precision strike capabilities. This decision follows the Army's Milestone C approval, a critical acquisition checkpoint that clears the way for mass production after years of design, testing, and limited operational deployment. The PrSM program represents a defining shift in the Army's approach to long-range fires. Rather than developing new launch platforms, the Army has chosen to enhance existing assets such as the M142 HIMARS and the M270 MLRS, both of which have been extensively combat-tested and proven in multiple operational theaters. The compact design of the PrSM allows 2 missiles to be loaded per launch pod, doubling the firepower of current systems while extending range and accuracy far beyond the legacy ATACMS missile it replaces. This simple yet transformative improvement allows field units to dramatically increase their strike output without retraining crews or modifying launch vehicles. Lockheed Martin's production expansion did not begin with Milestone C, it has been in motion for months. The company has made substantial investments in its Camden, Arkansas facility, where much of the assembly and integration will occur. Production lines have been reconfigured to accommodate continuous throughput, and suppliers have been encouraged to accelerate deliveries of critical components such as rocket motors, guidance units, and warhead casings. This proactive preparation ensures that the transition to mass production will not suffer the typical delays that often plague defense programs at this stage. Lockheed executives describe this ramp-up as a coordinated effort between government and industry, emphasizing efficiency, scalability, and supply chain resilience. The tactical advantages of PrSM are significant. Each missile has a range of over 500 kilometers, nearly twice that of the aging ATACMS, and uses a combination of GPS and inertial navigation systems for precision guidance. The missile's open architecture design makes it adaptable for future upgrades, including advanced seekers, alternate warheads, and new communication links. In operational terms, this means that a HIMARS battery, previously limited to 6 ATACMS missiles, can now deliver 12 PrSMs across twice the distance, enabling deep strikes on critical infrastructure, command posts, and air defense systems without relying on manned aircraft. This flexibility is vital in contested environments where survivability and mobility are essential. The introduction of PrSM also carries major implications for strategic deterrence. In a world where adversaries are deploying layered air defenses and sophisticated anti-access/area denial systems, the ability to strike deep behind enemy lines without exposing aircraft or ships is increasingly valuable. PrSM-equipped units can engage high-value targets from standoff ranges, shaping the battlefield before joint forces even arrive. This capability supports the Army's vision of integrated, multi-domain operations, where ground-based fires complement air, naval, cyber, and space assets in a synchronized campaign. International demand for the missile is also growing rapidly. Several U.S. allies, including Australia under its Land 8113 program and multiple NATO members in Eastern Europe, have expressed strong interest in acquiring PrSM to strengthen their own long-range fires capability. This aligns with broader efforts to increase interoperability among allied forces while expanding deterrent power across regions vulnerable to aggression. For Lockheed Martin, these foreign orders not only represent additional business but also contribute to stabilizing the industrial base and reducing per-unit costs over time. The company has confirmed that production lines are being scaled to accommodate both U.S. and allied orders. Still, producing 400 advanced precision missiles per year is a complex undertaking. Modern weapons rely on intricate supply networks and precision manufacturing processes that demand flawless coordination. To ensure consistent quality, Lockheed has implemented dual inspection systems, automated measurement controls, and enhanced traceability for every component that enters assembly. The U.S. Army has also intensified oversight to ensure reliability remains high as production expands. Environmental stress testing and acceptance trials are being increased to verify that each missile performs to specification under a range of conditions. This rigorous approach reflects the understanding that, at this scale, even small deviations can have significant consequences. The industrial challenge is mirrored by strategic necessity. The conflict in Ukraine and rising tensions in the Indo-Pacific have exposed the critical importance of munitions stockpiles and the ability to replenish them rapidly. Western arsenals, once thought adequate, have proven vulnerable to depletion in prolonged conflicts. The PrSM program's scale-up addresses this concern directly by ensuring that both the United States and its allies maintain sufficient capacity for sustained operations. By building at this pace, the Army not only strengthens its immediate capabilities but also signals to adversaries that the U.S. intends to sustain a credible, ready, and replenishable deterrent force. For soldiers operating HIMARS and MLRS systems, the transition to PrSM represents a profound leap in capability without adding complexity. The missile fits seamlessly into existing logistical systems, and crews can load and fire it using the same procedures they already know. This simplicity reduces training demands and shortens deployment timelines, allowing new units to field the missile rapidly. Combined with the system's shoot-and-scoot agility, this ensures that PrSM-equipped launchers can strike and relocate before enemy counter-battery fire can react, a decisive advantage in high-intensity conflicts. In broader military terms, the arrival of the PrSM marks a return to large-scale, industrial-era missile production, but with the precision, efficiency, and adaptability of 21st-century technology. It demonstrates how legacy platforms can evolve to meet modern threats through smart engineering and scalable manufacturing. For Lockheed Martin, the challenge is both technical and logistical, building hundreds of missiles that each must perform flawlessly under combat conditions. For the Army, it is a strategic milestone that redefines the reach, tempo, and deterrent value of its land-based fires. The U.S. military's shift toward long-range precision strike systems reflects an understanding that future wars will hinge not just on platforms but on the ability to deliver accurate, immediate effects from safe distances. In this context, the precision strike missile stands as a central pillar of the Army's modernization roadmap, a weapon designed not simply to replace ATACMS, but to transform how ground forces engage, deter, and prevail in the complex battlefields of the coming decades.